Hi, I'm Kelly Rosario. I'm the Director of Curriculum and Instruction for the Parkland School District. And tonight we delivered a presentation to our Title I parents on primary mathematics and the foundational skills that are necessary for students to be successful in math. We talked about basic number sense, operation sense. We talked about basic facts and when it's appropriate to start teaching your students the basic facts, and we talked about getting to the algorithm and all of the foundational skills necessary to be successful in upper grade level mathematics. It was a good night, a lot of parents showed up, and I was happy to present.
So I'm excited to be here. As Marge said, my name is Kelly Rosario. I'm the Director of Curriculum Instruction and Professional Development. I don't know about being an expert in this area, like she said, but I was an elementary math specialist for 9 years in my career, so if that qualifies. So tonight we're going to talk about the foundational skills necessary for students to be successful in mathematics. And I know a lot of you maybe have been struggling with some of the new ways that math is coming home with your children doing homework. And so we're going to hit some of that and hopefully explain to you why we are teaching math in a different way from when you and I were in the classroom. We did a lot of memorizing, we did a lot of procedures, formulas, and now I think you'll hear as the hour goes on that it's more about the understanding and the thinking and the problem solving and making sense of numbers. So I'm going to attempt to get through these 4 topics tonight. First one being early number concepts and number sense. And then we're going to talk a little bit about addition and subtraction concepts, basic addition facts, and how you can help your student with the facts. It's a little bit different from flashcards like we were used to. And then we're going to get into the algorithm. That's the subtraction procedure or the addition procedure where we regroup or borrow, as you may have remembered. Okay, we get there, but it doesn't come until after these foundational skills are in place. Okay, so the first thing are number big ideas. Okay, and some of these things seem really simple to us as adults, but to young children, this is even before school starts, these are really critical skills that students need. They need to know how to count and tell how many things are in a set, that numbers are related to each other in many ways, that they're all around us. Numbers, we encounter math in all kinds of ways throughout our entire life. And having number sense means that you can think and use numbers in different ways, flexibly. Okay, so children must construct these ideas that are up here. Okay, this is some of the first, very beginning math concepts. Number sequence, they have to know the name and the order of the numbers. Okay, one-to-one correspondence, they need to be able to count a set of objects and know that this is 1, this is 2, this is 3. If you'll notice, very early counters might go 1, 2, 3, 4, 5, and they're not necessarily understanding that's one-to-one. Cardinality, this is understanding that the last number said, when counting a set, is how many are there. Again, it sounds simple to us, but when they count 1, 2, 3, 4, 5, they have the one-to-one, now they know there are 5 things here. Okay, and then subitizing. That might be a new word. That is quickly recognizing and naming how many objects are in a set without actually counting them. So to model this, if you'll just let me scoot out of here, to here, just to give you an example of subitizing, I'm going to lift up this paper, and you're going to see, real quick, for like 1 second, and you're going to see a set there, and you're going to tell me how many are there. Okay, you ready? How many were there? 5. Did you count 1, 2, 3, 4, 5? You subitized. You understood that there were 5 there because you know that that's set of 5. Okay, you can do something similar. Let me just change my set. Don't cheat. Okay, you ready? 9. What did you see? You didn't see 9 individual. You saw 3 sets of 3. You knew it was 3, and then you saw 3 of them. Okay, so you can figure out that that's 9. So when we say subitizing, that's what we're talking about. New word tonight, right? So those are some very foundational skills that they will need to move into higher level math. Okay, counting on and counting back. Forward counting comes pretty naturally, and that happens from the time they're very little. Every time you go up the steps, you might count, and so there's a lot of counting, and kids generally come to school knowing how to count. But the backwards counting is more difficult for students than the forwards counting. So one suggestion is, if you count going up the stairs, count back going down the stairs. Give your child experiences with counting backwards. And counting on. That means when they get a little bit further into math that they don't have to, if they're adding two numbers, they don't have to count every one, but if it's 7 plus 2, they can go 7, 8, 9. Okay, that's what counting on means. So this counting on and counting back are more difficult than just counting. Okay, the relationship of more, less, and the same. This is some basic foundational knowledge, but they need to understand these concepts and have some practice. So again, you could make a set with your chips that you got at home. You can make a set of 4 and have your child make a set that is more, a set that is less, and a set that is the same, just to get those terminology solidified. And the word less, that's the other point I wanted to make. The word less is more difficult for students than more. Think about it. From the time they're very little and they want something, they say more. They understand that, want more. So they understand that, but less is something that comes a little bit more, is a little more challenging. Okay, so we're moving into numbers 1 through 10. Again, this is all very foundational. Many students have those concepts under their belt by the time they come to school, but some do not. And if you have toddlers, some of those activities would be helpful for them. So numbers 1 through 10, children can learn to recognize a set of objects, okay, in a pattern, and tell how many are without counting, okay? And 1 and 2 more. They should know that, for instance, 7 is 1 more than 6, okay? And 6 and 2 is 2 less than 9. I'm sorry. So same thing here with the spatial relationships with those dice formations, subitizing that we just did. They should start to recognize these numbers. Okay, another important concept is anchoring numbers to 5 and 10. We call them landmark numbers. Those are numbers, base 10 we use all the time. But 5 is a good one to start with. So consider this. Okay, think of the number 8, and if a child thinks of the number 8 as a 5 and a 3, okay, they can manipulate numbers, and they think of it as a 5 and a 3. Or they think of an 8 as 2 away from 10. It can help them when they get to addition. So if you look at the numbers here, 5 plus 3, obviously, if they know 8 is a 5 and a 3, that's straightforward. But 8 plus 6, if they know that 8 is 2 away from 10, they can change that to a 10 plus 4 in their head. Everybody see what I did? So it says 8 plus 6, but I know if I have 2 more, I can make that 8 a 10. So if I take the 2 from a 6, and I know this sounds complicated to us, but when students get good at manipulating numbers and understand that 10, they, in their mind, can say that's like 10 plus 4, and I can do that real quick. That's 14. Okay? The 13 minus 8. If they think of the 8 as a 5 and a 3, they could take away the 3 from 13, have 10, and then take away 5 more and have 8. So it's decomposing numbers, breaking them apart, and dimming the lights. Yeah, it's tough to see the screen. Okay. So I know that we're going to come back to this idea in a little bit and have you practice, but composing and decomposing numbers like that. Think about the power of higher level mathematics when they get into 4th, 5th, middle school. If they're able to manipulate numbers in that way and think in that way, rather than just straight memorizing facts. Okay, so that's what we're talking about of anchoring numbers to those 5 and 10. Okay, part, whole. Whenever you're talking numbers, whether it's a subtraction that has the whole and then 2 parts, or it's an addition with 2 parts and 1 whole, it's an important concept, okay? Generally when teachers in the classroom focus on part, whole, they'll focus on 1 number for the class. So, in kindergarten they might focus on the number 5, and they'll do all kinds of activities with the number 5 and breaking the number 5 apart. If you look at this, okay, you have the 2 tens frame, which we're going to do, and on the back there's a 10 frame, and there's 3 squares. Okay, that could be a part whole, where the number might be 5. So you may put the number 5 in that bottom box and have them use chips to find all different combinations of 5. There are 2 parts to 5, so they may put 2 chips in the one, 3 in the other, and show that that's 5. Okay, and then what are 4 and 1, 5 and 0? They would find all the different combinations. So when we say part, whole, it's thinking of a number and what are the 2 different parts that can make that whole. And you can give them numbers, like if the number is 5, if you give them a 2, a 3, and a 4, which two numbers make 5? Okay, just to get some practice with that. Okay, as I mentioned before, 10 is a really important concept, okay, and a set of 10 should play a major role in the early understanding of mathematics. So as you get into the numbers 10 to 20, this is where a lot of our kindergartners struggle. It's much easier to do the numbers 1 to 10, and once they get into those teen numbers, it's difficult. And so it's important for them to think about 11 as a 10 and a 1, and think about a 12 as a 10 and a 2, and a 17 as a 10 and a 7. Okay, they're not ready to understand place values, pre-place value concepts. Okay, they're not ready to understand that there's a tens and a ones column. But when you think about 17 as a 10 and a 7, that makes sense and helps solidify those teen numbers. Okay, just like they should know that 2 more than 7 is 9. The same thing here. You know, 2 more than 17 is 19. Okay, so those concepts that we're developing in the numbers 1 to 10 would translate as we get into the numbers with the teens. Okay, I'm just looking at my notes here real quick. So you have these double 10 frames, and these double 10 frames are really helpful with the teen numbers. So if you take out your chips, okay, and fill one whole 10 frame with one color, they're two-sided colors, there's a red and a yellow. And then you fill the bottom 10 frame with 6. Okay, so the top 10 frame, 10, the bottom 10 frame with 6.
Same color on the bottom or different color?
You could do a different color on the bottom than the top, just to make it stand out. Okay, when students visually see this, they can see that 16 is a 10 and 6. Now that's a hard concept. When you think about it, all the way through their life, they're thinking 10 as 1, 2, 3, 10 separate things. And now all of a sudden we're saying a 10. It all of a sudden becomes a singular thing. And that's, we know that because we've been in math and this has been our world, but for small children, that's a new concept. This is a 10 and 6 more. So 16 is 10 and 6. Okay, so this double 10 frame we're going to come back to. You can leave the chips there right now if you'd like. Okay, so numbers to 100. We get through the teen numbers. The rest kind of, you know, have a pattern. The 20s and then the 30s and then the 40s, and it all follows that pattern. So it's teens that are different from all the other numbers. But numbers to 100 is typically, by the end of kindergarten, students are able to count to 100. And they need to become familiar not just with counting, rotely counting to 100, but the patterns that are within the 100. And another gift you got tonight was the 100 chart. So on one side, it's a 100 chart with numbers, 1 to 100, and on the back side, it's blank. Some kids love, honestly, some kids just love to write the numbers in once they know the numbers to 100. So you could use a dry erase marker or a crayon, and they should be able to be wiped off on this laminated paper. So the back's for that. But I'm gonna have you do an activity for the front. This is a really important tool in the classroom. I mean, this teachers refer to all the time in our primary classrooms because of all the patterns on here. And when you look at a 100 chart, you can see the patterns. You can see the 10, 20, 30, 40 going all the way down the right side, okay? And then there's more patterns within here. I mean, if you look up at the number 1 and look diagonally, you've got 12 and then 23 and then 34 and 45. There's some patterns going on there. So there's a lot teachers do in the classroom with this. But something you can do at home with your child, I'm gonna have you do it right now, is to have one of you, working partners, one of you cover some numbers with your chips, and then the other one figures out what number's under that. Now obviously that's not going to be a very hard task for you, but talk about how you know what number's under there. Okay, what are the patterns on here that you know what number was hidden? So do that for just a minute here. One of you hide some numbers, and the other one talk about what number's hidden. this way? 65, so you just count it straight, right? Kids can also see that, right? Okay. Okay, did you all get a chance to practice that at least once? Okay, now some of you may have found, how did you know that? You may have known just because you counted straight down. Did anybody use a pattern to know? Like if you covered 56, did you know because above it was 46 and below it was 66 that must be 56? Okay? So those are the kind of patterns that, yeah, no, I hear you. Just kind of playing games. Kids find these things as games. You're hiding a number and I need to figure out what number is under there. And for them to explain why, not necessarily counting by ones, but looking for those patterns in there. Okay, it's important to bring this number sense we've been talking about into the real world, and home is the perfect place to do that because you go to the grocery store and you drive in the car and you have all these real world life experiences with your child right near you that are all teachable moments. So estimation and measurement are two great areas that can be supported in the home by about how many do you think that is? About how far do you think that will go? Asking those kinds of questions. Will it be closer to 5 footprints or closer to 20 footprints are questions you can ask. Will the apple weigh closer to 10 blocks or closer to 30 blocks? They don't necessarily, when they're very young, understand what a pound is and how much that is, but use something that they do now. They know how much this block weighs in their hand. Do you think that's going to weigh more or less? Some questions. How many footprints wide is the hallway? Those are questions that you can bring out when you're in the grocery store. Which one is bigger? And getting those concepts down when they're younger. Okay, so we're going to shift now a little bit into the operations. Specifically addition, we're going to talk about tonight, but developing meanings for the operations. What we're trying to do is we're help children connect different meanings, interpretations, and relationships to the 4 operations: addition, subtraction, multiplication, and division, so they can accurately and fluently apply these operations in the world setting. Now, I know when we were in the math classroom, at least when I was, it was pretty straightforward, and the teacher told us, here's where you must start when you add. You must start in the ones column, and then you must put this 1 up here when we're regrouping, and then you must add this column. And I can remember being the math student that struggled. I didn't really know why I was doing that. I was doing it because my teacher told me to do that. I didn't really know that was a 10 I was putting up there. It was very procedural. And you're going to notice that it's shifting a bit. We get to that procedure because it's an efficient procedure that works. But there should be a lot of number sense development prior to that, so they understand what's happening when they do put that 1 up there. Okay, so we're looking for operation sense, for students to be able to use those 4 operations, know the relationships between addition and subtraction, and then multiplication and division, and be able to manipulate numbers within the operations. Okay, contextual problems. The other thing when we were in the math classroom, it was just numbers. Pretty much a whole worksheet or a whole page where it was just the straight arithmetic. And you're going to notice a lot more problem solving going on, where there's arithmetic but within a problem situation. And honestly, that makes a lot more sense to kids when it's in a situation that they can understand rather than just a straight number. So like an example, okay, this is in a classroom. Yesterday we were measuring how tall we were using the connecting cubes. We saw how many cubes long, and when we were lying down. So the students were lying down, they were measuring how tall they were. Okay, Dion and Rosa were wondering how many cubes long they would be if they lay down head to foot. Dion measured Rosa, and she was 84 cubes long. Rosa measured Dion, and she was 102 cubes long. Let's see if we can figure out how long they are when we put them together. Okay, that's a pretty big math problem. 102 plus 84. We're not going to ask first graders to line up the numbers, but guess what? Through problem solving, they can figure out that bigger math problem even before they're ready for the algorithm and the lining up of the 10s and the 1s. Okay, so putting it into a context of a story where they're involved is going to help them understand the concepts before we get to the procedural part. Okay, so you'll see a lot of problem solving and encourage that. Okay, so you're combining the use of contextual problems, like I just talked about, and models. That's what you have in front of you, those little counters, drawing, when kids draw pictures to help them solve problems, okay? That's a model. Number lines is an important tool. That will all help them construct meaning of these operations. It's also important to teach addition and subtraction together, okay, because they are related. And so when you teach them together and they see that relationship, it helps them understand. Okay, so there are a couple strategies. When they first start doing addition and subtraction, they're probably going to do direct modeling, where they're actually putting out the chips, 3 plus 4, and then counting 1, 2, 3, 4, 5, 6, 7. Okay. Then they'll go into counting strategies, where they won't have to necessarily use those chips. They might put 3 chips out and know it's 4, 5, 6, 7, start using that counting on, but they'll start going to strategies. And then eventually the derived facts, which is what we talked about earlier, okay, 5 plus 8. If you think of 8 as a 5 and a 3, you'll know that that's 13 quick, because 5 and 5 is 10 and 3 more, okay, being able to manipulate and decompose numbers. Okay, so I know a lot of times, and I remember this too, and I remember with my kids, you know, they'd come home with the word problems, and the reading alone sometimes would challenge them. And so they would get frustrated, not be able to do the math because they didn't necessarily couldn't read it or didn't understand what they were reading. So something you can do to help with that is to ask them questions and help them make meaning of whatever the problem is. And whether drawing pictures helps them do that, getting models out helps them do that. The important part is understanding what's happening in this situation. So they know, are we going to join numbers together? Are we taking things apart? What's happening in this problem? So that I can understand what I need to do mathematically. Okay? You can act out the problem. That can be fun at home, right? You can put it on a little show and act out. Okay? Drawing pictures is always helpful too. But it really is critical for them to make sense of the mathematics. So we're certainly not going to have kindergarten, first and second graders understand and know the words commutative property and associative property and the zero property. But the concepts behind these 3 properties, they should understand in these primary grades. Okay, we're not necessarily using these words, but they should know that 5 plus 6 is the same as 6 plus 5, and it doesn't matter which one comes first with addition. Okay, they should know that when I have 3 numbers, it doesn't matter which 2 I add first. I don't have to go in order. In that example up there, 4 plus 7 plus 6, most kids are going to do 6 and 4 first, because that's a 10 fact. And they get to know those 10 facts. And then they can quickly add on that 7 to get to 17. And the zero property. Numbers, you know, it might sound simple to us as adults, that 0, when there's a 0, there's really nothing to add. But some students really struggle with that 0. And don't get that. Okay, so let's talk a little bit about addition facts. So number relationships, what we've just talked about, all of the things that we've just talked about, are really important to have under their belt before they even begin to try to memorize or know their facts. Okay, if we are pushing the facts before they have those foundational skills that we just talked about, it's not going to stick. And they may be able to memorize it for a short time, but most likely won't be able to decompose and compose numbers like we've been talking about. So those foundational skills, we shouldn't push the facts too soon. By second grade, students are generally ready to really start diving into the facts. Okay, they have all those foundational skills we talked about. It's a developmental process, so some students in second grade will pick up on the facts quick, and others it will take a longer time. Okay, but the drill and kill, the flashcards, are not necessarily the best way for students to remember their facts. I like to say they know their facts, not necessarily memorize, because they can, if they know a similar fact and can get to the other fact quickly, then that's great. You know, so when I say know their facts, it's not necessarily like this, but within 3 seconds is a good judge. Give them a little bit of thinking time. Okay, it is extremely important that students develop this fluency, though, with numbers. So, and it is something that the core standards support. Okay, they do think the facts are very important, and so do we. So what are basic facts? Addition is combinations with both add-ins are less than 10. So 9 plus 9, up to 9 plus 9. And then subtraction facts correspond. So 18 minus 9 equals 9. Okay, would be the subtraction facts. The mastery of the basic facts means a child can give a quick response, which I just talked about 3 seconds. Okay, and this is typically at the end of second grade. And as I've mentioned, the number sense piece is really critical for this. Okay, so we're going to talk about the reasoning strategies, which is phase 2. I already talked a little bit about counting strategies. They need to actually use objects to count the fact. They need to actually have it laid out and count each one. The reasoning strategies can really help students solidify these facts. And then eventually they move into mastery, where they just know their facts. So the reasoning strategies help students move away from counting and be more efficient with their facts, being able to recall them quickly. Okay, and here's another time where you can use story problems to help students understand their facts. So these are all the facts. I'm going to just go through quickly each one of these. Okay, but these are strategies that are taught in the classroom and can be supported at home when students are learning the facts. So the first one's pretty straightforward: 1 more than and 2 more than. Okay, so any number plus 1 or plus 2 is something that they can generally quickly do. And so story problems are a good thing to pose here. There were 7 ducks on the farm, 2 more ducks joined the farm. How many ducks are on the farm? That's 2 more. So 7, 8, 9. Okay, adding 0. When you add 0 to any number, the sum is always that number. And like I mentioned earlier, this is sometimes a challenge for students. If you use that part whole again, and sometimes in one of the parts have nothing to show them, so they can physically see that there's some numbers in one part and the other part is nothing, and then there's a whole. Okay, that's a physical model of that. Using 5 as an anchor. Okay, we talked a little bit about using 5 as an anchor, and we talked about this concept already. If they know that an 8 is a 5 and a 3, plus 5 more, they can break that apart into a 10 plus 3. Okay, make 10. This is a really important strategy, and generally kids do get their 10 facts. They know all of the different combinations of 10. And you can use your 10 frame and use the 2 different colors of your chips and find all different kinds of combinations of 10. So they can put 5 red and 5 yellow, they put 7 red and 3 yellow, so that they can physically see the 2 parts of a 10, okay, to help them with that. Story problems again, where you use 2 numbers that make 10, okay. But knowing these combinations of 10 gives them something to springboard off of as they get into higher numbers and place out your concepts. Okay, so we're going to practice this one, but let me explain it first. Up over 10, okay? Some facts have numbers that are have sums that are greater than 10. So it's fast. Once you get to 10, it's fast to add on the rest of the numbers. Okay, so getting to 10, and we've practiced this a little bit. So students use their known facts that equal 10 to solve the basic fact problems. Okay, so here's an example: 6 plus 8. The student might start with the larger number and see that it's 2 away from 10. So we've got an 8, it's 2 away from 10. Therefore, they take 2 from the 6 to get 10, and they add on the remaining 4 to get 14. Okay, you know, and I see some of your faces are kind of going like this a little bit. You would be surprised at how young children can think this way, because they don't have a set way like we do. And so when they start manipulating numbers like this, numbers aren't so scary. And as they get into 4th and 5th grade and are using these numbers, they have a really good, solid foundation, which is important. So we're going to practice this. This is next, okay? So I would like you to take your mat with the side, that's the 2 10 frames. And we're going to do 7 plus 4, okay? But here's what I want you to do. I want you to model each number, model 7 on the top and model 4 on the bottom 10 frame. So don't put them together yet. 2 separate numbers, a 7 on top and a 4 on the bottom. Okay. what students can do is to make that 10, what I kind of did mentally on the last slide, where 8 is 2 away from 10, they could do the same thing here. So you see a 7, and how many blank spots are there? Okay, it's 3. So in order to make 10, they can move the 3 from the bottom up to the top and fill that 10 frame. So go ahead and do that. Fill your 10 frame. And you can quickly see now that 7 plus 4 equals 11, okay? It's physically right in front of you, you can see that. So if you have some addition facts and have them do that, they physically see it before they can just do it mentally, like I was explaining to you. Okay, doubles. Students, there's something rhythmic about doubles, and students seem to pick up on these. But it is important because there's another strategy next that we're going to talk about that springboards off of doubles. Okay, when you add a number to itself, it's a double. So you'll see all the doubles are listed on the slide here. And there are anchors for other facts, like this one. Okay, so we call this one neighbors, or doubles plus 1, or near doubles. We've heard it called all of those things. But when there are two numbers right next to each other, like a 6 and a 7, or an 8 and a 9, okay, we call them neighbors, or doubles plus 1. Okay, and so they take the fact they already know, like 6 plus 7, they know 6 plus 6 is 12 because they know they're doubles. And they know they have to add one more because 7 is one more than 6. Okay? Or they can think of it as 7 plus 7 and take away 1. Okay, if they think of 6 plus 7. So this is a good strategy that I actually physically see students using when they're figuring out a fact. And this is what I mean by a quick recall, not necessarily memorizing. So if they don't know 6 plus 7, but in their head they can say 6 plus 6 is 12 and one more is 13. That's quick recall. So all of that happens, and sometimes as parents we want to show our children how we did math. So we want to show them that algorithm and teach them that. But I would suggest not moving straight into that before they really have a good understanding of all the other things we've talked about. Okay, so we do get to the algorithm, and let me just go through this part here to end the presentation. So up in the top box there we have 73 minus 46. And this is the way we know how to do it. We line up the 10s and the 1s. We must start in the 1s place. Okay, we can't take 6 away from 3, so we borrow from the 7. 7 becomes a 6, 3 becomes a 13. It's very rote. And it's not really getting to the concepts, because that 7 is not really a 7, is it? It's a 70. Okay, but this is how we learn, very procedural. And we all know how to do this, and it works. But I'm going to show you kind of the process that your children are going to go through before they learn this. Okay, so this might be something you've seen come home on homework if you have a second grader. Okay, some of these strategies. And you might look at it and go, oh my God, why are they doing it? Why is that long, long way of doing it when all you have to do is line up the numbers and do this, this, and this? And it's because there are a lot of skills and a lot of sense making that's going on before they get to the algorithm. So let me just go through a couple of these examples. It's very small, and I realize you probably can't see it so good. So this is what we call an open number line. And it's just a line. You can take any piece of paper and just draw a line. It's an open number line. So the problem is 73 minus 46. So what they're doing here is they're counting up. Okay, because it's a subtraction problem. But remember, addition and subtraction are related, and they've gone over this, and they understand the relationship between addition and subtraction. So here we are. They're going to count up. They know they need to get to 73. And so they're going to start at 46, and they're going to figure out how much do I have to count up to get to 73. So this student started at 46 and added 20 to get to 66. Then they added 4 to get to 70, and then 3 more to get to 73. And then they added how many hops they took in all as they counted up. So 20 plus 4 plus 3 is 27. So my answer is 27. Okay? So they're physically actually hopping to figure out how many. Let's look at another example. Okay? This one, again, they start at 46, and they get to one of those landmark numbers I talked about. They get to 50. Then they're going to hop 10 to 60, 10 more to 70, and 3 more to 73. And when they add them all up, again, you get 27. Okay, so they're using the counting up method to figure out a subtraction problem, using this open number line. But think about all the math concepts. We're going to get to that algorithm. But when we get there, they're gonna have a more solid understanding from doing this. Okay, so this is just some examples of counting up. Here are some examples of takeaway, which is a way to understand subtraction. But again, that relationship, counting up is a perfectly acceptable strategy for subtraction. Okay, so the same idea here, except for they're gonna start at 73, and they're gonna hop back on this open number line. So they're gonna hop back 40, and they can do that, okay, it gets them to 33, and then 3 more, and 3 more. And now they need to make sure that they're taking away 46 up here. So they took away 40, now they took away 43, and now it's 46. So they took away 46, and where did they land? They landed on 27, okay? That's the kind of subtraction we think of, that we count back and we take away. So this way works too. Okay, this one might blow your mind a little bit, but they started at 70 instead of 73 because it's an easy number to work with. And this is, children invent these ways and it makes sense to them. They started at 70, they took away 40, they took away 6, but they had to hop back 3 because they started with 70 instead of 73. Now, if you think about a second grader who can manipulate numbers this way, they understand numbers. They can manipulate and work with. It might seem confusing to us as parents that didn't learn it this way, but there is a lot of sense making of numbers going on when students are using these strategies. Do we want them, when they're in sixth grade or when they're in algebra class, to draw an open number line and be doing addition and subtraction this way? No, and they won't be. But all of this work in the primary grades to really wrap their head around these numbers is gonna actually make them stronger when they get to those math skills in Algebra 1 and beyond. So you do a lot of work like this. They understand that I can subtract by counting up, I can subtract by going back, and here's how it works. Okay, now we're ready to start thinking about that algorithm because they've got the foundation skills they need. So when we begin teaching subtraction, we're gonna use models. We're not just gonna put numbers on a paper, but we're gonna use models. And if you can see, these are 10 strips. So they're little strips, and there's like 10 little grooves in them to show that there's 10 ones in a 10 strip. And then these are ones. And these are your double 10 frames that you have in front of you. So they model the number, okay? So they have 45 minus 27. So they lay out 40, 10, 20, 30, 40, 5. And they want to take away 27, so the number cards are there for them to know what they're taking away. Okay? Now, I need to take away 7, but they can physically see there's only 5 there. Okay? There's not 7 to take away. So I'm going to take one of my 10s, and I'm going to trade it in for 10 ones. Take away that. Now I've got, so you can see there's 17 here. I mean, there's 15 here. Okay? Now I can take away my 7. You can see they're taking it away. I can take away my 2 10s to get my answer of 18 left. So they're actually going through the steps using models to show what they're doing when they put that 1 up there. Okay, they know it. They've had all these experiences. And then finally, we get to what you know, okay? But listen to the verbiage, it's a little bit different. We're lining up the 10s and the 1s. We can't take 6 1s away from 3 1s, so we borrow 1 10 from the 7. 7 10s, 70, becomes 6 10s, 60. And 3 1s are now 13 1s. Subtract the 10s and the 1s, and the answer is 27. So now we've got greater depth of understanding, okay, for the subtraction and number concepts. We've got multiple tools. If they forget this procedure, they could draw their number line and they can do that hops and they can get there. And there's nothing wrong with doing it multiple and different ways. In fact, that is encouraged in the math classroom these days. It is not, this is the one way you must do it. It is, how did you solve it? And how did you solve it? And guess what? Kids learn so much from the way other kids are solving problems. It makes sense to them when they hear their peers solving a problem, okay? So, and what also happens here is all math concepts lead into another math concept. It might not be for the next year or for 2 years down the line, but if they don't really have a solid understanding of the concepts, to transfer that knowledge to a new, harder concept later is gonna be really hard, and they're gonna have to relearn what they learned in a previous grade. So really having that understanding is gonna help them move forward faster because that concept is going to be solidified. Okay? So you have a handout in your packet. It's on a blue piece of paper, and it is a list of different ways that you can help at home. Okay? Just ask your child to talk about math. I know sometimes when they're very young and it takes them a long time to get their explanation out, but it is so important for their processing to talk about it. How did you learn this today? Okay, asking them that. Teach your child math by teaching him about money. Home is a perfect place to learn about money because you're using it all the time. Okay? Talk to your child about how adults use math. They see that it's an everyday life kind of thing. Okay, talk about people who use math in their jobs. Okay, so I'm not going to read through every single one on here, but there are a lot of different ideas for you. And like counting and measuring and estimating are great things to do at home. And have fun. Show your child that math is fun. There's a stigma out there sometimes that, even if you weren't the best in math, don't tell your kid that. Don't tell them I was never good in math. Okay, make math fun, because the more fun it is and the more game-like it can become, the more they're going to learn and understand. Okay, I am open to any questions that you may have at this point. Anybody have questions? Yeah.
What role do the specialists play in the classroom on a day-to-day basis?
What do you mean by specialists? The reading specialists. Okay. So the reading specialists mostly focus on the literacy and the reading class. Okay, and they do a lot of interventions and work with teachers on literacy. But we do have our Title I teachers. Often will work with small groups of students during math time and support them. And a lot of our math classes are run that way. It's not teaching to the whole class like when we were in school. It's small groups, so that if I've got 8 kids around me as opposed to 25, I can see exactly what those 8 students are doing. So the Title I aide may take some students, the teacher takes some, students are working in centers. It's a very active class. Okay. Yes, in the back there. Thank you. Multiplication? Yes. Okay. Yep. Great question. So she's asking multiplication facts. When does that come into play, and should we force them to memorize the facts like we did? It follows the same pattern that I just talked about for addition and subtraction. So when they go into 3rd grade and they're learning, they might learn a little bit in 2nd grade, like equal groups. They might learn that, but then in 3rd grade they'll do more concept development of multiplication. I would not push the facts until they understand what multiplication is and when you need to multiply in a story problem situation. Once they understand the concept of multiplication, the same kind of thing. There are strategies for students to learn. They have some facts they know. They can, like mine is, I know 8 times 5 is 40, but when somebody asks me 8 times 6, it doesn't come right to me. But I think of 8 times 5 is 40 and then 8 more. So having those strategies, not necessarily the drill and the kill, but understanding the concepts and then they should, by 4th grade, know their multiplication facts. Okay, you're welcome. Any other questions? Yes?
So you're saying, I know you said not to have them memorize, but they should pretty much memorize the doubles and
They should know their doubles.
And how to make a 10.
Yes, they should know their combinations of 10. Yes, those would be really important things for parents to work on. She asked, she said not use the word memorize, but should they know their combinations of 10 and their doubles? And I said that's a really good idea, and students usually pick up on that. They do a lot of work in the class, but that can absolutely be supported at home. Any other questions? I just ask that you hang in there with us, support your child. Do you all know about the Math on the Spot videos? Let me show you that real quick.
Kelly, while you're pulling that up, the PowerPoint that you used tonight is on the Title I website. It's under the parent resource and parent workshops. But if you have trouble finding it, you can either give your reading specialist a call or give me a call and drop me an email and I can email it to you. But all of the ideas that she shared tonight are in that PowerPoint that's out on the Title I website.
Okay, let me get to our main district page. These videos have been very helpful for parents. They go right along with our Go Math program, and they are like 4 to 8 minute clips of somebody teaching the lesson your child learned that day. So if they bring a math sheet home and you're like, I don't really understand what they're doing, you can go to here and I'll show you, it gives you the chapter. So if you go,
The projection is going right.
thank you. I just have to find it. I believe it is under curriculum. Let me scroll up here. And it's down further. It's under this screen is not quite big enough. There's parent resources under it. There it is. Okay, grab it. Okay, under parent resources, Go Math lesson videos, math on the spot. Okay, let me scroll up so you can see that. Right here, Go Math lesson videos, math on the spot. So when I click on that, it's going, it's spinning. There we go. So here's the Go Math page. The grade levels are on the side. So say I have a first grader, and on the top of their paper, their homework says it was 4-2. That means chapter 4, lesson 2. So I would go to chapter 4, and I would go to lesson 4.2 over here, and click on it. I don't have sound right now on this computer, but there is sound, but you'll see that the video will come up. Most of the time is Professor Berger, that's the character's name, and he'll come up and he explains the lesson that day with a little puppet, a little kind of Muppet character. Kids love it, teachers sometimes use it in class, but it's a great resource for parents if you're not quite understanding the math. So that's the opening of it. This one happens to be 2 minutes and 55 seconds, so they're not real long, and they're just a way for you to understand what's happening in the classroom. Okay? Yes?
Sometimes when you calculate.
Yes.
And I don't know if you see my speeds
Yep.
only
Okay, so her question was about the calculator. And she was wondering if it's good for her child to use the calculator so he can physically see it, or if he's being lazy, is her question. So here's my my ideas on the calculator. At the age of your children, with kindergarten through 2nd grade, they're really, other than to check their work and have fun with being able to use a calculator after they've done the math, I would suggest not giving them the calculator to do their math. They should be understanding the concepts. There comes a certain point by 4th grade that the math gets a lot more complicated and there's a lot of multi-step kind of problems, and the lesson might not necessarily be on multiplication or division, but it's on something else and they need to multiply and divide. That's when we put a calculator in the kids' hands as a tool. Okay, we know they understand the concepts and that they're needing it to solve these multiple step problems. So we suggest up through 3rd grade that there's not a whole lot of calculator use. It's fine for them to check their work because it's fun for them to use the calculator, but I would have them do their work first and then let them check it with the calculator. And then teachers generally go by that rule. When they're first introducing a concept, they're not using the calculator because they want the students to understand, like reducing fractions or adding and subtracting fractions. At first, no, we're not going to use the calculator because we need them to understand the concepts. Once they get it and they're solving problems with addition and subtracting fractions, then they can use the calculator. Okay, you're welcome. All right, well, thank you so much for coming out tonight. It's great to see a big crowd, and good luck. Let us know if you have any questions. Thanks.